Welcome to Cinemeric Live, application technology made easy. The aim of this series of short videos is to present specific topics on the practical use of Cinemeric. Today, we continue with the second part of our special video series on flexible CNC programming. First of all, I'd like to point out that the individual parts of this video series build on each other and should therefore be watched in chronological order. I'd also like to encourage beginners to broaden their knowledge with these videos. In the first video, I explained what flexible CNC programming is useful for. If you haven't seen it yet, please watch it first. By the way, you can find the links to all parts in the video description. Today, we're going to look at the user variables for flexible CNC programming. First, I'd like to show you just what types of variables are available in Cinemeric. Then I'll explain the data types of the variables, something you should really internalize. This is followed by what is probably the most important topic for CNC programming, the local user data. Finally, I'll be showing you how to use global user data to create permanently available variables. I'm here at the programming workstation in the CNC job planning. It's best to use a virtual CNC for the creation and, above all, the testing of flexible CNC programs. In this way, the ongoing production operation is not interrupted, and it's usually easier to focus in the office. At least that's what I find. However, this requires an offline programming tool that behaves exactly like the CNC in the machine. That's why I use Run My Virtual Machine, the virtual image of Cinemeric 1, because Run My Virtual Machine uses the same NC kernel. Parameterization of the CNC, that is the machine data, is also identical to the machine. So, my virtual CNC behaves exactly like the real CNC. The Cinemeric Operate user interface is also identical to the one in the machine hall. And if you're working with machines with Cinemeric 828 or 840D, you can use Cinutrain for offline programming instead. But now, to today's first topic. Let's take a look at which variables are available with Cinemeric in the first place. A distinction is made here between variables that are permanently available in the CNC and those that are only temporarily available while the CNC program is running. Let's start with the system variables. These variables are available as soon as the CNC is switched on. Cinemeric stores all the data relevant for machining in these variables. The variable names always start with a $sign and can be read in the user program, such as the current spindle speed. But why should I want the spindle speed to be read? I wrote the value myself in the CNC program. Let's imagine we're programming a user cycle. The spindle value is not located in the cycle, but rather in the calling main program. Furthermore, the operator can change the spindle speed at the machine with the override. Therefore, we must read out the system variable. Next, let's look at the global user variables. These are variables that are created retentively, that is permanently, in the memory. If I turn the machine off and then on again, these variables are still present. As a machine user, I can define global user data myself. This is my own machine data, so to speak. We'll see how this is done later. Other examples of retentive variables are the R parameters. These are variables that Cinemeric sets up for us users. They've been around since CNCs exist, so they're relics from the old days. However, R parameters are not entirely conflict-free. Let's imagine that the early shift uses R0 as the drilling depth, and the late shift uses R0 as the milling path in feed. And there's our conflict. Today, however, Cinemeric offers us a large number of R parameters, so such conflicts can be avoided, of course. However, I hardly ever use R parameters, only for testing my user cycles, for example. For this purpose, I store values for remembering in the R parameters. In my CNC programs, on the other hand, I consistently use local user data. Local user data are variables that I create myself with readable names. They are only there as long as I need them, which is from the NC start until the M30 end of the program. But more on that in a moment. Let's take a quick look at Cinemeric Operate. You can see the R parameters in the operating area parameters under user variables. Thanks to a recent innovation, R parameters can now also be commented. This is good because it reduces the potential for conflict. Now that we know the different types of variables, let's look at the data types of variables. That sounds a bit strange at first, but it's normal to specify the type of the variable with any programming tool. So, now let's look at the data types, what they mean, and their range of values. Let's begin with the variable type integer, which means whole number. Imagine that we need a counter in our program. This counter certainly doesn't need decimal places. The value range of the integer is approximately between plus and minus 2 billion. That should be enough. Floating point numbers are another important variable type, variables of the type real. At the latest, when we specify machining positions, we need the decimal places to be able to machine precisely to the micrometer. The value range of the 64-bit real variables is more than sufficient in accuracy and size. Then there's the variable type character. This variable is only 1 byte in size and contains exactly 1 ASCII character. These can be combined. A string is nothing more than a string of characters. This allows us to work with texts containing up to 255 characters. Variables of the bool type are used less frequently. They are exactly 1 bit in size and contain the value true or false. They can be used to remember conditions for program branches. The frame variable type is specific to Cinemeric. These variables can be used to store entire coordinate transformations. We'll take a closer look at this in one of the next videos. For the sake of completeness, the axis type should also be mentioned. This type is also Cinemeric specific. I can use it to remember axis identifiers. Now, that was all pretty theoretical stuff. But once you've understood this, it's worth it because you can use this knowledge perfectly for other programming tools as well. Now that we've learned about the types of variables, we now come to a tool that I use almost every day in CNC programming, the local user data. These are variables that are only needed during the program's runtime. Let's take a closer look. Here we can see a CNC program in the CNC editor that's still empty. While I create this small CNC program, I'd like to explain the syntax. Let's enter the first instruction, the language command def. This is how we define our local user variables. By the way, CNC blocks with the def instruction must always be placed at the very top of the program. This is also the reason why we can't define variables in shop mill and shop turn programs. because there the program header is at the top. Machining step programming is just not the right tool for flexible CNC programming. Instead, it's about quick and easy programming. For maximum flexibility, which we need here, the G-code editor is the ideal choice. The def command is immediately followed by the data type for the desired variable, in our case, an integer, followed by the name of the variable, counter, in this case. Please always be careful when assigning the name, because this name must not be the same as the CNC commands, system variables, or variables of the machine manufacturers. If there are any identical names, an error message will flag them up when the program is started. By the way, you can already assign values to the variables when you define them. If you don't specify anything, then the value is default, for example, 0 for integers. Let's move on to the next definition. This time, it's a floating point number with the name xposition. Incidentally, you can define multiple variables of the same type in one CNC block. Now let's create a string variable with the size of 100 characters. And now a real variable. Here's the special feature. With the command LLI, lower limit, I can specify the lower limit. With the command ULI, upper limit, the upper limit. Our variable for the groove width may therefore only assume a value of between 0 and 100. If a value outside this range is assigned, an error message appears. What can I do with the variables now? Let's continue in our CNC program. For example, I can read the current position of the x-axis from a system variable and assign it to our user variable xposition. I can memorize the value of this variable in an R parameter. By the way, R parameters also have the data type real. Now I assign text to my string variable. I output this variable with the message command as a message for the operators at the machine. I'll show you what else you can do with the text variables in one of the next videos. During the runtime of the CNC program, I can view the current value state of my local user data in the Parameters operating area and also change it if necessary. We've now seen how we can work with our local user variables. However, the lifetime of these variables is limited to the runtime of the program. So, the contents of these variables are not permanently saved. But I can use the R parameters for a retentive backup of values. R parameters are not self-explanatory in contrast to variables with names. Now let's talk about global user data. First, we have to create a definition file for our GUDs. For this, we change to the commissioning operating area. Now we enter customer as the password and switch to the system data mask. We position the cursor under NC data on definitions and select the name UGUD under new. The definition file ugud.def then opens in the CNC editor. As with the local user data, we also use the def command here. The nck command defines that this variable is available in all channels of the CNC. The same syntax follows as for the LUDs, a real variable with a lower and an upper limit. Now, the next definition. CHAN states that the following variables are to be provided in each channel of the CNC. And again, we use the same syntax as for the LUDs. So now, the variables for the change point of the turret are available separately in all channels. Next, close the definition file and simply answer yes to the question of whether the GUDs should be activated immediately. The variables appear instantly, ready for programming. Both the global GUDs and the channel GUDs can be displayed and defined in the Parameters operating area of the User Variables screen. This is done in the same way as for the R parameters. So that's all on today's topic, User Variables for Flexible CNC Programming. I'll show you how we can use these variables in upcoming videos, so be sure to stay tuned. And at this point, I'd like to mention the CNC for You newsletter. If you haven't already done so, it's best to subscribe to the newsletter right away. Simply enter CNC for You in your internet search engine, sign up, and you're all set. The newsletter contains useful information about using Cinemeric as well as about the Cinemeric Live videos. This way, you'll never miss an episode. Thank you for watching, and see you next time.